So, in a previous math class, you were probably taught a rule for dividing a number by a fraction. Today we're going to talk about why that works. I do not want you to be focusing so much on the rule, which some of you already are, but on, well, why does this work? So, Madison and Ramona were working the following problem, but they each did it in a very different way. Here's what Madison did. She took a square, divided it into 5 equal pieces, and shaded 3 of them. That's 3/5, right? Everybody's good with that? Okay. She then divided the square into 3 equal pieces horizontally. Where did that 3 come from? Well, it came from here, right? From the 1/3. This makes the square contain 15 pieces, but its value is still 3/5, right? Because I've got 9 pieces out of 15 is still 3/5. Now, what they've done here, and there's not an easy way to show this, is they have rearranged it. They took maybe these 2 off the bottom and filled it in up here. And then took this piece and filled it in there. So the first row of shaded pieces is 1/3. So that's a full 1/3. On the second row, she has 4 out of the 5 that she needs to make 1/3. So the answer is 1 4/5. Now, could you do this? Yes. Does this take way too long? Oh, yes. But this is why it works out, right? Once we have done this, we have a full 1/3 and then 4/5 of a 1/3. So here's what Ramona did. She said, okay, 3/5 divided by 1/3, you could write it this way, 3/5 all over 1/3. Then she went, okay, I could multiply by 1, and she multiplied by 3/1 and by 3/1. And what that did for her is in the denominator, it makes 3/3. And what's 3/3 equal to? 1. In the numerator, she had 9/5, so it's 1 4/5. So she did what she called a super fraction, like okie dokie. So let's do what they did on each of these problems. And yes, this is more work than you want to do in the end, but I'm hoping so you can kind of see why our method for this works. So let's start with a square. And I would divide it into 5 equal pieces. And I'm going to shade in 4 of them. And I'm going to switch colors. Now I'm going to divide that into 2 parts, the other direction, because my denominator here is 2. I'm going to move this little block up here. What do I have? Well, I have 1 complete set here, and I have 3 out of the 5 that I need to make the other one. Sorry? thought someone said something.
Yeah, when you missed.
I'm sorry?
The answer.
Oh, okay. Let's do it the other way. So I'm going to rewrite this as 4/5 over 1/2. Then I'm going to multiply it by what they called a super 1. And I want this denominator to become 1, so I'm going to multiply it by 2 over 1. And multiply this by 2 over 1. So this is just 1. So that makes 8/5 over 2 seconds, or 2/2. That's 1 3/5 over 1, which is just 1 3/5. All right, let's try this one. So I'll draw a square. I'll divide it into 2 equal sections, and I'll shade in one of them, because that's 1/2. Then I'm going to divide this into 3 sections going this way. And then I'm going to move this one up here. Now, it says I'm dividing by 2/3 here. So I want to have a complete 2/3. How many boxes would need to be shaded in to have a complete 2/3? I've heard so far.
Those 4.
You would need 4 to have 2/3, right? So this whole thing is 2/3. How many parts do I have inside of that? 3 out of the 4 that I would need. This is 3/4. Now, the other way, we'll do 1/2 over 2/3. I want this number on bottom after I multiply to become 1. What do I want to multiply this by? 3/2. So I'm going to multiply by 3/2 over 3/2. That's going to give me 3/4 over 6/6. Which is 3/4 over 1 is 3/4. So you could do these things. However, let's take a look just at this. In the end, with this second method, did the denominator really matter in the end? No, what really mattered was this part, which is the original fraction times the reciprocal of the second one. So that's the only part that we actually need in order to get our answer. So let's do that on these. So if I have negative 5/8 divided by 1/3, that's the same as negative 5/8 times 3/1. That's negative 15/8. And we'll always go ahead and make those into mixed numbers at the end of the problem. By the way, partway through the problem, it's usually a bad idea to switch it to a mixed number if you're still doing more operations on it. So 8 goes into 15 one time with 7 left over. That's negative 1 7/8. For this one, if you have something that is a mixed number, we'll make it an improper fraction. Who can tell me what that improper fraction should be, Adela?
7/4.
There we go, negative 7/4. And we'll have times negative what? Anyone? 5/2. So what sort of an answer will I get? A positive or a negative? We're going to get a positive. That's going to be positive 35/8. Which, let's see, 8 goes into 35 4 times, and it's 32. So there's 3 left over. So 4 3/8. All right, let's look at a couple of word problems on these. So Gerard loves to cook. His aunt visited Switzerland and brought him back 4 pounds of Swiss chocolate. It's a lot of chocolate. Gerard's favorite recipe takes 3/4 of a pound of chocolate. How many batches of chocolate cookie recipe can Gerard make using all of the chocolate he has? So we're going to take all the chocolate that he has, 4 pounds, and we're going to divide it by 3/4. So we're asking, how many groups of 3/4 can I get out of 4? So that would be 4/1 times 4/3. So that's 16/3, which is 5 1/3. By the way, if you wanted to, occasionally I have students who are like, I got confused part way through, so I needed a diagram or something. Well, let's think about that. I'm going to divide these into fourths, and because I'm not doing anything else, I'm just going to divide them this way. And I want groups of 3/4, right? So that's one group of 3/4, right? And then I'm going to do polka dots for the next one. So now I've got 2 groups of 3/4, right? And let's make this one go the other way. So it's 1, 2, 3. So now I have 3 groups of 3/4. Let's make another group of 3/4. So now I have another group of 3/4. And now I want another group of 3/4. I have 5 groups of 3/4. And how many do I have left? I have 1 out of the 3 I need to make 3/4. So that's why it's 5 1/3. You're breaking this into groups of 3/4. Again, drawing it takes a really long time, but if you ever get stumped, you're like, okay, I know how to make a diagram that'll help me. So Lauren was bringing food to a party. She brought a 4-foot sub sandwich and cut it into servings that were each 3/5 of a foot long. How many servings did she get if she used the whole 4-foot sandwich? All right, so we have this 4-foot sandwich and we're dividing it up into groups, into sections that are each 3/5 of a foot long. So that's 4/1 times 5/3. So that would be 20/3. 3 goes into 26 times with 2 left over. So she would have 6 2/3 servings. The last one is not going to be as long as all the other ones. All right, questions about that? Okay.